Hi there. This interview is designed to simulate a real-world DevOps interview focused on Google Cloud Platform. You will hear questions that test how you think about reliability, scaling, networking, cost, and failure in GCP environments. As you listen, pause after each question and answer it out loud before you hear the sample response. Treat this like a live interview. Think through your assumptions. Explain your reasoning clearly. If this style helps you prepare for real DevOps, cloud, or SRE interviews, subscribe so you do not miss the next session. Let's begin. First question. Tell me about a time you had to learn a new cloud service quickly in order to solve a production problem. A strong answer might sound like this. In one case, I had to quickly understand how cloud load balancing behaved in front of a managed service because we were seeing intermittent failures. I focused on understanding the request flow first rather than the full feature set. I read the official docs for the specific component involved, validated assumptions using logs and metrics, and tested changes in a lower environment. The key was narrowing the learning scope to what mattered for the incident instead of trying to learn everything at once. Second question. Describe a time when you disagreed with an architectural decision related to cloud infrastructure. How did you handle it? A good answer could be, I try to separate the technical concern from the people involved. In one case, I disagreed with a decision to run stateful workloads on ephemeral compute without sufficient backup planning. I clearly explained the risks using examples and potential failure scenarios. I also proposed an alternative that balanced cost and reliability. Even though the final decision was not exactly my preference, documenting the risks and mitigations helped the team make an informed choice. Third question. Tell me about a production incident where you did not immediately know the root cause. A strong response might be, in that situation, I focused first on stabilizing the system rather than chasing the root cause. I reduced blast radius, rolled back recent changes where appropriate, and gathered data from logs and metrics. I communicated clearly with stakeholders about what we knew and what we did not know. Only after the system was stable did we perform deeper analysis. That approach helped avoid panic-driven decisions. Fourth question. How do you balance speed and safety when making infrastructure changes in the cloud? A solid answer would be, I think in terms of reversibility. If a change is easy to roll back and low risk, I am comfortable moving quickly. For changes that are harder to reverse or affect critical paths, I slow down and add validation steps. Using infrastructure as code, staged rollouts, and monitoring gives me confidence to move faster without sacrificing safety. Now let's move into the technical questions focused on GCP. First question. Can you explain the difference between regions and zones in GCP and how that affects availability? A strong answer could sound like this. In GCP, a region is a geographic area, and each region contains multiple zones that are isolated from each other at the infrastructure level. Zones are designed to fail independently, so spreading workloads across zones protects against localized failures. However, zones within the same region still share some dependencies. So, for higher availability or disaster recovery, you may also consider multi-region designs. The trade-off is complexity and cost. Next question. You are running a workload on Google Kubernetes Engine and traffic suddenly spikes. What are the first things you check? A thoughtful answer might be, I start by checking whether the cluster is scaling as expected. That includes node autoscaling, pod autoscaling, and whether any resource limits are being hit. I also look at load balancer metrics to confirm traffic patterns and backend health. At the same time, I watch latency and error rates to understand whether scaling is keeping up or if there is a bottleneck elsewhere, such as database connections or external dependencies. Third question. How do you approach networking security in GCP for a production application? A good response could be, I think, in layers. At the network level, I use VPC design and firewall rules to restrict access. At the service level, I rely on identity-based controls, such as service accounts and IAM. I also prefer private connectivity between services whenever possible and avoid exposing resources publicly unless required. Logging and monitoring are essential so that misconfigurations are detected early. Fourth question. What role does IAM play in GCP and what mistakes do you commonly see teams make? A strong answer might be, IAM controls who can do what on which resources. The most common mistake I see is over-granting permissions for convenience. Teams often use broad roles instead of fine-grained ones. Another issue is not auditing permissions regularly. I prefer least privilege by default and gradually expanding access when needed, along with periodic reviews to reduce long-lived risk. Fifth question. You are asked to reduce GCP costs without hurting reliability. How do you approach that? A realistic answer could be, I start by understanding usage patterns. I look at which services drive the majority of cost and whether that usage aligns with actual demand. Then I look for safe optimizations, such as right-sizing, using auto-scaling more effectively, or adjusting storage classes. I avoid aggressive cuts that could impact availability. Cost optimization should be iterative and data-driven, not reactive. That concludes the first part of the interview. Let's continue with deeper technical and scenario-driven questions focused on GCP. Next question. You have a service running on compute engine behind a global HTTP load balancer. Users in one geography report slow responses while others are fine. How do you approach diagnosing this? A strong answer might sound like this. I start by confirming whether the issue correlates with a specific region or backend service. I look at load balancer metrics to see latency by backend and by client location. Then I check whether traffic is being routed to the expected backends, or if health checks are failing and forcing traffic to less optimal locations. I also review instance-level metrics to see if CPU, memory, or disk are saturated in the affected region. If everything looks healthy at the infrastructure level, I investigate application-level latency and dependencies such as databases or third-party APIs that may behave differently by region. Next question. How do you decide between using GKE Cloud Run or App Engine for a new service? A thoughtful answer could be, I start by understanding the workload characteristics. If the service is containerized, stateless, and benefits from rapid scaling with minimal operational overhead, Cloud Run is often a good fit. If I need more control over networking, scheduling, or sidecars, GKE gives that flexibility, but comes with more operational responsibility. App Engine can work well for simpler applications that fit its model, but I am careful about platform constraints and portability. The decision is less about which service is best and more about which trade-offs the team is willing to accept. Next question. You are using Cloud SQL for a production database and notice increasing latency during peak hours. What steps do you take? A strong answer might be, I first confirm whether the latency is coming from the database itself or from application behavior. I review Cloud SQL metrics such as CPU usage, memory pressure, and connection counts. If connections are the bottleneck, I look at connection pooling and application patterns. If CPU or I/O is saturated, I consider scaling the instance vertically or evaluating read replicas. I also review query performance to see if inefficient queries are causing load. I avoid scaling blindly without understanding the root cause. Next question. How do you think about service-to-service authentication in GCP? A solid answer could be, I prefer identity-based authentication using service accounts rather than shared secrets. When services run on GCP-managed platforms, workload identity allows them to authenticate securely without storing credentials. I design access so that each service has only the permissions it needs. I also ensure that permissions are auditable and rotated automatically where possible. This reduces both operational overhead and security risk. Next question. A GKE cluster starts evicting pods unexpectedly during normal traffic levels. How do you investigate? A strong response might be, I begin by checking node-level resources to see if memory or disk pressure is causing evictions. I look at pod resource requests and limits to see if they are misconfigured. If pods request too little memory, the scheduler may overpack nodes, leading to eviction later. I also review recent changes such as new workloads or configuration updates. Understanding the relationship between scheduling decisions and actual usage is key to fixing this long term. Next question. How do you design for disaster recovery in GCP without over-engineering? A thoughtful answer could be, I start by defining acceptable recovery time and data loss. Not every system needs multi-region active setups. For many workloads, spreading across zones and having backups is enough. For critical systems, I consider multi-region replication and tested failover procedures. The key is matching the design to business requirements and regularly validating that recovery plans actually work. That concludes the core technical portion of the interview. Now let's move into the pressure section. These questions are intentionally unclear and uncomfortable because that is how real cloud incidents feel. First scenario, your production workload runs primarily in one GCP region with zonal redundancy. Google reports elevated error rates in that region, but no full outage yet. Some users are impacted, others are not. You have a secondary region available, but failover has not been exercised recently. What do you do? A strong answer might sound like this. I focus first on limiting user impact while avoiding irreversible decisions. I verify whether the errors correlate strongly with the affected region and whether traffic can be reduced or routed more selectively within the region. At the same time, I assess the readiness of the secondary region by checking data replication status and deployment health. If impact continues to grow and confidence in the primary region drops, I prepare for failover with clear communication. I avoid waiting passively for an official incident update if users are already affected. Next scenario. A security scan reveals that a service account in GCP has owner-level permissions in production. Removing those permissions might break unknown automation. Leaving them increases security risk. How do you approach this? A thoughtful answer could be, I start by understanding how that service account is being used. I audit recent activity and identify which resources it actually touches. If the risk is high, I prioritize reducing permissions even if there is potential disruption. I may introduce temporary monitoring or logging to catch breakages quickly. If the risk is lower, I plan a staged permission reduction with validation at each step. Security debt should not be ignored, but it should be paid down in a controlled way. Next scenario. Your GCP bill spikes significantly overnight. Finance is alarmed and wants immediate action. The system is still stable. What is your response? A strong response might be, I acknowledge the urgency but avoid reactive shutdowns. I identify the services driving the cost increase and correlate usage with traffic or recent changes. If there is runaway scaling or misconfiguration, I cap it carefully while monitoring impact. I communicate clearly that cost reduction is underway, but that availability remains the priority. Long term, I put alerts and budgets in place to catch similar issues earlier. Next scenario. During an incident, engineers suggest different solutions. Some want to roll back, others want to push a fix. Time is passing and users are impacted. How do you lead? A mature answer could be, I take responsibility for making a decision. I ask which option is safer and more reversible. If rollback is known and low risk, I prefer that over pushing an untested fix. I make sure the team is aligned on the plan and focused on execution. Clear direction matters more than consensus in these moments. After stabilization, we can analyze and improve. Final scenario. A critical dependency outside GCP is failing intermittently, and it is affecting your application. You do not control that dependency. What do you do? A strong answer might be, I look for ways to reduce coupling and impact. That might include adding timeouts, retries with backoff, caching, or temporarily disabling non-essential features. I communicate clearly with stakeholders about what is degraded and why. If possible, I work with the external provider, but I assume resolution may take time. My goal is to protect core functionality and user trust. That brings us to the end of this GCP-focused interview. These scenarios reflect the kind of decisions engineers face when systems are complex, information is incomplete, and pressure is real. What matters is not just knowing GCP services, but knowing how to reason, prioritize, and communicate when things go wrong. Take a moment to reflect on which question challenged you the most. Was it handling regional instability, managing security risk, controlling cost, or leading during an incident? If this format helps you prepare for real interviews and real-world cloud problems, subscribe so you do not miss the next session.